Hello, this video is an introduction to loops with PCG inside Unreal Engine. I am not a developer by trade, and so picking up how to use loops and the kind of intricacies of dealing with arrays inside loops in PCG has been a challenge to learn. So I made this video for those of you who are also having difficulty understanding what loops actually are and how you might utilize them in PCG graphs. This is actually an excerpt from a coaching call I do with Aziel Art Academy members every month. And if you're interested in joining the Academy as well to join awesome calls like this, more information about that in the description. This call, we had the great pleasure of having a guest with us, Procedural Minds, who, if you're not familiar, has a wonderful PCG channel that is really good at breaking down the details and using more intricate PCG setups to build things like structures. I've learned a lot from his channel, so I was really excited to have him on the call, and I hope you all will get a lot out of it as well. Enjoy.
This is not going to be nearly as nice as a video that is spent edited down and nice. This is called live. It's no, it's a crazy new concept. But I'll go ahead and just get started with just creating a spline and a PCG graph. So that way I can just put it all in a spline. It'll be easier to manage the volume. At least I prefer it for this kind of stuff. Let's go ahead and create a blueprint, create a PCG graph. I'm just calling it loop demo, as that is what it's going to be. Okay, so I'm going to add myself a spline, regular spline, and because I'm feeling lazy, I'll just alt drag it out and then search close loop and close it. Good enough for that. And now PCG graph, we'll add ours in. Feel free if I'm going too fast. This is this thing that happens every single time. So I figured this part can go through really quickly.
Yeah, I can jump in here and give a little quick add-on here. So the reason I've asked you to cover loops to begin with is because it opens up a lot of possibilities for what you can do with arrays. So arrays and loops are intertwined in usefulness. An array is just a bunch of pieces of data, but multiple of them in an array assigned to an index number. And what loops allows you to do is loop through an array of meshes, an array of names, an array of different things. So it's super powerful for those of you who are a little more like, what is loops? Why are we here?
Yeah, I'll share the power. But so here's the PCG graph, very basic one. I'm going to get my spline data, which is the spline I just created, the graph. I'm going to use a spline sampler, and we're going to be sampling it on interior. Oh, this is different in 5.5. First time I'm using 5.51. Unbounded is still a thing, even in 5.5. When you're using on interior, always check unbounded. I don't know why. To this day, I don't know why. In 5.2, you do not need to select unbounded on an interior spline. But in 5.3 and above, you need to always select unbounded on interior. So now we have a bunch of points. Let's reduce the amount of points. I'm going to change the interior sample spacing, say 250. There we go. Now you can actually see the points. Loops, basically, in PCG, after 5.3, so basically 5.4 up, is considerably easier. If you're in 5.3, dear God, may everyone help you with that, because I had to deal with 5.3 loops just recently, and it's such a pain in the butt. And 5.4 plus, it's easy. So we're going 5.4 plus on this one, and it's the same in 5.4 and 5.5. The reason I say it's a complicated in 5.3 is because effectively the way loops are now designed was not implemented. That was all implemented in 5.4. Let's say I want to do a simple transform points, and I want to just move points upwards. Let's say 100 units into the air. Well, this will move them all 100 units into the air. If I press D and sample the correct one, they're all moved 100. In fact, let's move them like 1,000 so it's be more noticeable. Right, so this is all of them. Now, what if you do want to do all of them? What if you want to do half of them? What if you want to do the first one or every other one, etc.? So this is where loops come in. Now, the way loops work is basically it's a graph within inside a graph. You just create yourself a new graph, same thing, PCG graph, and I'll just call it loop. And you just take the graph and you drag it in, and then you can have the option of creating a subgraph with it or a loop node. I'll select a loop node. You can also just search loop to create a subgraph loop and pipe it in. That is also an option. Press the button and it populates in. I prefer to drag it in just so you know you're grabbing the exact correct one, and you just created it, so it's usually just right there anyway. But when you create a loop, you can see nothing's there. But if I open it up, you get an input and an output. By default, it is spatial and anything. I'll go ahead and double click on it to open it up. And now I can open these and start modifying the input and output. This is where you specify kind of what goes into this loop and what goes out of the loop. So for the output, I can open up my pins and I have the output pins. So here it is usage normal, allow types any, pin status advanced. So I don't want allowed types any. I want to get point information out. So I'm changing it to point for allowed types. There's a bunch of options. You can get volumes, you can get attribute sets, landscape information, tons of stuff depending on what you're looping on or what you're doing with the subgraph in general. Because maybe you just want to do a pass through. You can even do a pass through if you wanted to, right? You can just pass input into output so you don't have to drag it out from somewhere else. If you want, you can even create stuff like that. The pin status here is advanced. What advanced means is if I have nothing plugged into it, you don't see it unless I open it. So that's the default. Personally, I always change it to normal for the output. So that way you just always see it. Because I prefer to just see my outputs unless it was one of those not mandatory ones. So I always change my outputs to normal. As for the input, default is spatial. Now, in our case, we're dealing with points, which is this blue one here. So again, instead of spatial, I'm changing it to point. I'm changing pin status. Now here, you can change it to required. Required means that you need something plugged into this. Now, this is not as important when you have only one input, but when you have a lot of inputs, this can be quite important. In our case, I'll leave it as 1. I'll still keep it on required though. But here in usage, we have normal, loop, and feedback. Feedback is a complicated thing, which we might get into a different time. I'm still wrapping my head around it because it is effectively, you could send information from the output back to the input on every single loop. That's basically how it works as a short version, but we're going to be covering loops. Using feedback loops is how you would create a loop with break, for example. Because basically you would pass through a bool that says, hey, was it successful or not? And whether or not it's successful, it stops the execution on the loop. There's really nice benefits with feedback loops, but it is far more advanced than the basic loops. So for now, we will cover the base loops system. So now we have this. Now I can do the same thing as I did before. I can take this transform points, for example, paste it in here, plug this all the way through, and remove this guy and plug it in here. Now the thing is, it's exactly the same because we've just told it to, hey, go through all your points and move them all up. That's not fun. What we want to do is move, let's say, some of them up. So in a loop section, in a loop setup, you can right click and set get loop index. And now you can have some fun with this because now you can be like, okay, based on the loop index, let's go ahead and move some of them up. What we can do now, something like using a branch, and if we plug the input into the branch, and open our branch up, output to B is true. So I'll plug in B into our transform points. And I'll say, if our loop index, let's say it's less than, I'm using a create attribute. I can put another number in here. I'm waiting for the day when they change this to be able to just be typed in like every other blueprint, but I understand why it's not. But you can use a create attribute to basically type a value in. So as long as it's less than, let's say 100, then go ahead and transform points. And you'll notice
Sorry, can I ask a quick question here? So for those of us who are less familiar, can you do a brief explanation of what the index number is, what it represents?
The index number is the point. So if I press A here, you can see all of these points. It has all the information on the points down here. And the index is this number down here. All your points go in order. They always start at 0 and then it increments upwards. So you can either have a index of 1 and then an index of 7. It'll always go 0, 1, 2, 3, 4, 5 in order. Now, depending on how you do this, how you sort this, how this has been created, they might be in a different order, but they'll always be indexed 0 to whatever the final number is. Final number is -1, I guess, because it starts at 0.
So the points that we get when sampling a landscape, sampling a spline, are they in an array by default as their kind of format, which is why this is working? Okay.
Yep. They're always in an array because right here you can see we have a single point data and here are all the arrays. Now, I've told it to do based on the index less than 100, but you might notice that, well, they're all still up. Well, why is that? Well, that's because the index here is always less than 100. And this is the part where when you get started with loops, people get confused on because it's like, okay, I'm looking at my numbers. I have clearly over 100 here. Why am I not looping on this? Well, that's because it loops not on this index here. It loops on the PCG point data, which has an index of 0 and only 0. Effectively, you need to make all of these points have their own point data. And thankfully, there's a simple node for that. So before this PCG loop, there's a lovely node called attribute partition. And by default, it'll always error out. But in the attribute partition section here, you can specify what partition you want to do. If I press this plus button and change it to index, and then press A to get the information, you'll see you only have 1 point. But here are all your points. And you can see the same thing, 0, 1, 2, 3, same thing. There's an array of points, but now they've been separated out by their index. Okay, so I have 384 total points. Now, I can separate it out by lots of different information. I can even pipe in a custom thing here. And basically anything that matches will go into its own thing. So if I had multiple things that were the same position, so let's actually do that. If I did a position, it's all separated out because every single one of them has a separate position, but I can do a position.x. And now I've separated them out based on their x position. So you can see all of the x positions here are negative 590. If I select any other one, they're all the same, negative 1090. So you're able to basically split all your points up by whatever data you want into their own point data. And we'll go ahead and keep it on index. So each one of them is separated out, and then push this through. The other thing I'm going to do is, instead of pressing D in this node, I'm just going to drag out and search for a debug node, which does the same thing, effectively. So that way I don't have to keep pressing D somewhere else. But all of a sudden now you can see, well, we have only 100 of these up, but what happened to the rest of them? Why are the rest of them gone? Well, it's because we're not outputting. If you don't output a point, it goes poof. Now you can pipe it right into an output node directly like so, because last I checked, you cannot create another output node. So unlike blueprint loops where you can create thousands of output nodes and just be like, okay, let's plug it in from here, plug it in from there. All of them have to go into the same output node. But now that we say, okay, if it's the first 100 of these, please move them up 1,000 units. The rest of them, the ones that fail, just push them through. That's going to be the start of it. But now we can have some real fun because now we have the setup. So what if we want to do every other one or every third one? What you can do now is, instead of using the loop index and just checking if it's less than something, you can use a modulo. Now, a modulo effectively is a division that returns a fraction. It divides the numbers and then returns to you something after the decimal point, effectively. So where division will get you, like, if you divide 8 by 3, it'll return you 2 point something. This will just return you the point something. In my case, let's do modular. And again, I'll use a create attribute. And I'll set it to be 2. So whatever the index x modulo 2. But again, we're getting the fraction. Like, what do we do with that? Well, you could check if it's greater than 0. So if there is any information on it at all. If it cleanly divides, or rather doesn't cleanly divide because we're doing greater than 0. If it doesn't cleanly divide, then do this. Otherwise, just do what you were doing before. And now we're getting every other one moved into the air. Now doing this manually, right, would be kind of a pain. But now you have this automatic, which means you can also change now this attribute. So if I want to, I can just select 3. And now you can see every third one is down below. 2 out of 3 are up in the air. And if I wanted to, I could just simply swap this around. Easier option. And now 1 and 3 is up in the air, depending on how you want to achieve this. This is kind of the premise of loops. You first go through...
I have a quick question. For a branch node, is it always just 2 outputs? What if you want to like 3 different choices? Do you have to kind of cascade branching nodes?
There's a node called switch, specifically for that reason. So switch, which might be a 5.5 node now.
I think it's 5.4.
It's 5.4? Okay.
Yeah.
Switch allows you to have an input, just like you have on a branch. And here it allows you to specify either an integer, an enum, or a string. So if I, for example, use an integer, oh, that's right, I did use this in the building series. So here on int options, I can just press plus, type in 1. You can see I now have a 1 there, add another 1, 2, 0, 1, 2, or I can say 5. And basically, then I just put in the integer selection section, my index, and I can be like, you know what, do this on 0, this on 1, this on 5. And you can do this based on an enum or a string. One thing to note about this one, though, is if you name things the same, so if I have 0, 1, 1, you don't get multiple outputs here. It just has 0 and 1. It's smart enough to be like, okay, you don't actually have multiple differences, so we're just gonna not even show it to you. So as long as you have it typed in as a different output, you can now do different things. Now, this has been all from the point information from our points. We took the index, we looped on them, and then we moved them. But sometimes you want to just loop a specific number of times. And looping at a specific number of times is more difficult than you would think, unfortunately, because you always need to have it separated by this BCG point data. And if you don't have this separated of some kind, it will not loop multiple times. So if you want to loop specifically 10 times, you would need to have something that has specifically 10 in this array, effectively. Now, there's ways of doing it. In 5.4, it's a more complicated process. In 5.5, there's a node called generate points, or point generator, that allows you to just specify the number of points you want to generate. It takes in a single point. So if I use get actor data, set to single point, so just the actor's information, I plug this in and press A on it. It says 100 and 100 entries. That's how many points you have. And if I change this to 150, 150. Problem with this node, though, is there is no inputs or outputs. If you're really good with HLSL, you can code it in. I'm not good with HLSL, so I'll show you the alternative, which is the 5.4 method of doing this. And the 5.4 method of doing this is using I believe it's the create points grid. So this create points grid, normally, I just sample it, just creates points in a grid. That's pretty much what it's there for. But with some math, it can be used to actually create the number of points you want. If I change the cell size to be with a divide, so what we're going to do is, for my calculations, use a create attribute set to 1000, divide by a number, let's say 2, of how many points you want, set that to cell size. And I believe I need to change 550 gets me now 2 entries. If I change this to 10, I have 10 entries.
If you have been getting a lot out of this call, or you're just tired of piecing information together from tons of different YouTube tutorials and you're not sure which things are up to date, you have questions, you're frustrated with courses and training being very general and not really specific to what you're struggling with and what you have questions about, then you might be interested in joining Aziel Art Academy. I've taught thousands of students over the years through my courses, my YouTube channel, private coaching. I also taught at university, and I've seen some students excel and just explode in their craft as well as creatively. And I've seen other students just kind of fall down this black hole of unfinished projects and just frustration, and they kind of hit a wall in their learning journey. And so I would often ask myself, what's the difference between these two students, and how can I build something that would really help people and give them all the support that they needed to really excel as artists, in this case as environment artists using Unreal Engine. And so I came up with Aziel Art Academy, which is a blend of regular coaching, personalized tutorials, a private community that comes around you and supports you in your projects, a place for you to ask questions, and of course over 100 and counting high quality video tutorials and self-paced training courses that really will fill out all the gaps in your knowledge. If this seems like something that you might be interested in, I have a link in the description that you can jump over to, and we can get on a call and talk about if it's a good fit for you. All right, let's get back to the tutorial.
All of a sudden, I've basically created the kind of the same functionality, but there is a slight problem with this. If I change this too high, if I want 1,000 points, I have 10 million entries. I don't think I'm going to 10 million when I say 10,000 or I say 1,000. That's because it is now so small that it's dividing into the 50s. So if I change this to like 0.001 and 0.001, now I have 1,000. It's just because we've now divided the pieces so small that within the 50 units, they fit multiple times. If you're never going to go that high, you can pretty much leave it as the default 550, 50. But otherwise, just make it a really small number for Y and Z. And now you can see it's 1,000 entries. If I do 10,000, we get 10,000 entries. Now, there is still a limit. 100,000 is fine. 1 million becomes 4 million. Because at that point, you'd want to, it needs to be even smaller fractions. But chances are you're not going to create 1 million points, because may God have mercy on your computer when you do that and try to loop on it, because that is going to be insane. But now we have a way of looping a specific number of times, right? So
can you real quick give maybe an example or two of using this in like a real world thing that you're building? Because I think a lot of us kind of get the concept of like, we sampled the landscape or the mesh or whatever, and we're doing stuff to those points to like spawn grass on it or something like that. What are like some situations where you would need to create these points from scratch, in this case, create your own array and use that as a starting point?
A lot of times it's more use cases of, I want to like combine certain things a certain amount of times. I use it in the building series, but it's mostly I mostly use it in scenarios where you have something that you want to do. You know how many times you want to do it, because let's say you have 5 floors of a building. Well, you know you need to loop on it 5 times, but maybe you don't have, your points are not, you don't have the points for 5 floors. But you know you need to loop it at 5 times specifically. So in scenarios like that, you would use this setup to specify, I want to loop it 5 times.
So you're just, in this case, you're decoupling point data from like their spatial, using them in your level, and you're more just using them to like do anything in your loop the certain number of times of points that you have. So you're saying like, yes, I need to do something 5 times. I'll just create 5 points and use that, the index from those points, to drive a loop doing something 5 times.
Yes. For example, if I want to do something, let's say 10 times here, we'll do a little demo here. So again, you have the points here, right? It's an index here. It's not in point data. So we need to get the attribute partition set to index again to get this information. again, this separates it out into here. So now we can use it in a loop, and I'll just go ahead and just plug the loop in here. Now, when I do this, we don't exactly get the same thing because the loop is not set up for it. So actually, you know what? Let's go ahead and I'll duplicate the loop and we'll use this new one. Let's save everything except the map. So for this one, I'm going to change what we're doing here. So we're looping on points a certain amount of times, right? So in our case, we're looping on it 10 times. So what you can do is do a transform points node, and I want to move it somewhere based off of a certain amount of times. And I want to actually copy the points every single time. Effectively, instead of piping in the location manually, what you can do is set up a loop index and then multiply it by how much you want to move it, basically. So I'll do another create attribute. This time, instead of double here, we're going to change it to a vector, and I'll say 500 units up. And then we're going to do offset min and offset max. So it moves it up directly based off of the loop index. And now we have it moving up. Now, in this case, we're not moving up anything else because we haven't plugged in our spline. So this is where you want to have multiple inputs. So on this one, we want to loop on these points, but we don't want to actually use them. We want to move up our spline points. So on our input, we can go ahead and create a new input here of also type point. And I'll just call the label our spline points. Pin status, we can set it to normal is fine or required if you want to make sure that's plugged in. And instead of looping on our actual loop information that we put in, we're going to put it into our spline points. Now, something to keep in mind with loops, I have nothing piped out of here, but that doesn't matter one bit. Nothing needs to be actually piped out of here. It'll still loop. So if you're using your loop just for a loop and just to specify how many times you want to loop on something, you don't care about the information from it. You don't have to drag out of it to use that information at all. But now in here, it is complaining because we have nothing plugged into the spline points. So we can plug in spline points. And all of our spline points have now duplicated 10 times. And we now have a grid of spline points. And this is because every single time that it goes through the points, it goes through all the points and moves them up. And then he does it again on all of the points and moves them up again. And every time we're outputting this, which means that every time you get the full points moved, next time in the loop it moved up, and we're outputting it every single time. Now, when you have a loop like this outputting, something to keep in mind is it does create separate point data for all of this. So if, for example, you didn't want to have them all separated out anymore, you would want to use a merge points node, and then you only have one again, and all your points have been combined. Again, you can do, for loops, now, you can also do things like only affecting one of these floors, because you can filter based on that information. Right now, I have it separated out by the floors, effectively, from floor 0 to floor 9. So what we can do here is use a filter points or point filter, and we can say if it is greater than, and we can say index, or actually let's do equal to an index specifically, and we're going to use a constant threshold for a filter, so we just pipe in a number here, and we're going to say 2. And now if I change this to 5, yeah, different column, 20, different column, because now it effectively is going through, and each one of the floor has its own array here. And so you can now specify, hey, I want this column. Now, if you were to do this with it combined, right, it would only get the 1 point. But because it's now partitioned based on the floors already, you're getting a column of the points.
And what if you wanted to get an entire like horizontal floor of the points? Where would you put that same filter?
For that, I believe it is, I would loop on these and only output a single one. So what we can do is, again, drag a new loop in here and just say, we're going to keep the loop index, use this to a double. So let's say I want index 2. If this floor index is equal to 2, and we'll loop it just on an endpoint here. We don't need the spline points on this one. Then output it, and instead of this, we now have floor 2.
Nice. Okay, very well done.
So effectively, right, once you have it partitioned the way you want, you can do it. Now, let's say this wasn't partitioned from the big get-go, right? Once you did this loop, this wasn't all nice. You had them all combined, but you still wanted to do this based on floor. Well, if I did a merge points, they won't be all nice and pretty, right? You only have one and they're all combined. Well, then you can use an attribute partition afterwards based off of its position, .z, so in verticality. And now here, I once again have that same information. And once again, I can pipe in through the loop and get the same result. Mm-hmm. So even if you're like, oh crap, I merged the points because I need the merge for something else. And later on, you're like, okay, I want to now separate it out. You can partition it which separates it out by point data based off of a certain criteria that you pipe in. And this could be attributes that you have added in manually as well. Because if you're doing something and using an add attribute, you could add things and configure it to your own liking, and you can filter it based on that. In this case, we're just using the default point information that just in verticality in Z.
A good example, real world example of that is, for example, on the biome tool that I'm building, I have an array of biomes, right? So I'm going through each biome and I'm taking the texture or the color that you have assigned to the biome and then dividing it and making a new parameter that, or rather taking that color that you entered and applying it to the actual point color data, which can then be used to filter or debug later so you can actually see where each biome is. So these attributes, they can jump around. You can make one, you can take it later and apply it to another attribute. You can take density value and then apply that to position. It's really flexible and also brain breaking as you're working through it.
Yeah, my brain is starting to break already. If you wanted to do something to each set of points in your floors, like if you wanted to transform each floor by 10%, where would you put that in this structure? Like if you wanted to do something, read which floor it was on, do something to those points, then on the next floor do something different to those points. Where would you put that? That would be inside.
You can do the switch method as we showed earlier. Here you just plug in your loop index into your integer selection, and then just in your integer options you just plug in 0, 1, 2, and now you can do one thing on floor 0. One thing on floor 1, one thing on floor 2, that's entirely separated.
And that can happen outside of the loop too. You could get the data out of the loop and then grab it.
Right.
In a loop, it makes it easy because you've now already filtered it by floors. And now this is just going to be like, this is floor 0 for the first time it goes through it, floor 1 the second time, etc.
This might be kind of off topic, but when you dragged the PCG in and it gave you the option to make it a loop or to make it something else, what was the something else and where would you use that?
So that is called a subgraph. It is.
Okay.
So if I go ahead and do that, let's see. So if I grab any one of these, the first one's a subgraph node, the other one's a loop node. Subgraph node, if I select it, has no loop functionality. If you just want a graph that is going to be repeated, it is basically like looprint functions. It is just
like a function. Okay.
Yeah. It's just a set of points or set of nodes that you can just drag out and keep reusing everywhere. So instead of recreating every single time, but it doesn't loop on anything. It's just basically a collapsed thing that if you want to, then you can maybe migrate to another project. Let's say you always do the specific configuration. You create it into a subgraph. Go ahead and just migrate that part of your code effectively somewhere else.
And if you edit that subgraph by double clicking it in the content browser, does that update the subgraph that you've dragged into another graph?
Yes, it's all linked.
Okay.
Yeah, so when I either open it here or double click on it, it just opens it in your content browser. Opens up here.
Used it in multiple different places. You edit the master and it always
exactly individual. And if you want something different, you just make a duplicate and then modify a copy of it that does something different.
Got it. Okay, great.
Yeah, it's super helpful if you're using a particular type of translation logic or noise logic on your trees and you want to use them on your grass or other areas, and then you reuse that graph, and then you can have parameters that go into the graph that change things about it, change the seed, change the density, whatever, but that logic can be reused.
You can always plug in another input here that's like a bool or a value or something, and then just have it again switch or branch and have it do one noise in one scenario, one noise in another scenario. And so instead of creating two separate nodes or two separate graphs, you have one with just an input that's like, hey, pick one, pick your option kind of thing.
Okay. And can you expose the parameters of the subgraph so that they appear in the details panel when you drag that in, so that you don't have to go actually double click it? Does it kind of expose it the way?
So that is under graph settings on top on the right here. As long as you have a parameter here, then it will be exposed. So if I make a new property here,
but I mean, for the subgraph that you've dragged in, do the parameters for that subgraph get exposed in the details panel when you click on the subgraph itself?
No, not in the detail panel. So the subgraph, so you have parameter overrides here. If in this graph you also created some, then those get exposed. So if I created
oh, they do. Okay.
Subgraph here of value 0, then here on a parameter overrides, you do have subgraph.
Oh, okay, good,
Value
great.
0.
Okay, good.
So yeah, you don't need to have it as an input if you just want to just manually do this. Inputs are there if you want to dynamically control this.
But,
Right.
but then, sorry, just to follow up on that other question. So if you do edit the master and you've used that, does it reset the parameter overrides?
No.
Or do those
No.
stay with each individual copy?
Yep, as long as you had it checked. So if you had it unchecked, it will use whatever
Yeah.
default it was, which
Yeah.
means if you change the default, it'll change the default. But if you
Got
have
it.
overridden this with a checkbox, no matter
Yeah.
what I change it to in the actual graph, so if I change it here
Still
to
keeps
10,
that parameter override.
it's still 0 here. But if I uncheck
Got
it,
it.
it'll go back to 10. If I recheck it,
Okay.
right out.
Okay.
I will say, Markley, there's a bit of a question when you make a subgraph because you can make a parameter inside of it, right? And then override it
Right.
from the outside. Or you can make a parameter outside of it and pipe that value in with an input and just have
Yep.
that plugged directly into your transform points, your other nodes. So
Yep.
both
Right.
work. But it might be a question for you when you build it. Like, do I want this parameter to exist outside the graph and be editable outside the graph? Or do I want to override it, double override one parameter with another parameter on the inside? Does that make sense?
I think so. My brain's got to like cool down a little bit before I can understand exactly. Yeah.
Yeah, and you can go deep with loops and overrides as well, because you can loop on loops. You put loops instead of loops. So
Don't
if you want
start.
to, you can loop on every single floor and then loop on every single point inside of every single floor. That's entirely possible. You would do it the same way as I did, create a loop instead of a loop.
Yeah, I mean, it is useful to think about real world uses for this because it's super cool, but I also need to attach it to something where I can think of this kind of thing being useful. So I'd be curious to hear. I mean, you said you've used this in some of your building tutorials, this kind of structure.
Yes, yeah, I do it specifically for like creating the floors.
Yeah.
A lot of times
Okay.
I use it for that. Because you need to a specific number of floors. It doesn't matter how many points you had on your main walls or floor. You need to move it up
Yeah.
a certain amount of times. So for
Got
things
it.
like that, that's where I kind of use the create points grid. Otherwise, most of the times I use the regular. Just take our points, partition it, and then let's make under certain criteria, let's make some of them be a little bit different than the others.
This has been absolutely wonderful. Thank you so much for joining. And I hope we can have you on again in the future.
I don't know about great. They're okay, but I'll take it.
This is something I've learned about. It was extremely self-deprecating.
Best of luck, guys.
Yes.
All right. Thank you.
Thank you so much. Yep. See you later.
Bye.
If you found this video helpful, I would appreciate a thumbs up or a comment. If you have any questions, like I said, if you're interested in joining the Academy and jumping on awesome calls like this, as well as getting access to the private group, personalized tutorials, and all my courses in one place, check out the link in the description. I will see you in the next one.